All right, in this video, we are going to cover special right triangles. This is a review from geometry, but essential for your understanding of the unit circle, which is our upcoming unit. So there's two special right triangles we're going to focus on, and the first is a 45, 45, 90. So there's a 45, 45, 90 degree triangle. And there's a lot of different ways to go through this. If you remember the way that you were taught in geometry, feel free to use that way. But the way that I like to do it is every 45, 45, 90. So I'm going to rewrite those angles right here. Every one of these triangles follows a proportion. So the sides that are opposite those angles are going to go right here. So 1, 1, radical 2. So those numbers represent a scale factor of the three sides that are opposite those respective angles. So if we saw this triangle, the side opposite this 45 degree angle we would label with a 1. The side opposite this 45 degree angle is also going to be a 1. And the third side opposite the 90 degree angle is a radical 2. So the three sides of the right triangle will always follow this format of a scale factor. A lot of times there'll be multiples of these numbers. And what we're going to do is we're going to set up a ratio. So the actual lengths of the triangle are going to go at the bottom of these fractions. So they'll go across the bottom, and usually these are going to end up being variables. I think you'll see here in a second how this process works. So before we do the other one, let's sketch a triangle that's about a 30, 60, 90. So here's a triangle that looks approximately like a 30, 60, 90 degree triangle. So when you do these are the ones that most students find the most helpful using this pattern. The lengths of the three sides of the 30, 60, 90 degree triangle are going to follow the format 1, radical 3, 2. And again, the actual lengths of the sides of the triangle are going to go down here at the bottom. You'll see here in a second where it's just a pretty simple cross multiplication process we'll do. The 1 goes opposite the 30 degree angle, the radical 3 opposite the 60 degree angle, the 2 opposite the hypotenuse. So let's use these patterns and see how they can help us solve some of these problems. So let's start again with a really simple one. Probably you can do in your head without using this process I'm going to show you. But this is a 45, 45, 90 triangle. I just want you to practice using this pattern. It follows the 1, 1, radical 2 pattern. And obviously this side that we know is not 1. It's opposite the 45 degree angle though, which means 8 is going to go underneath one of those 1s for our first ratio. This other 45 degree angle opposite it is the x value. So x is going to go underneath the second one. And then all that's left, this should be labeled a 90 degree angle. Opposite the 90 degree angle is our y coordinate. And now to solve for x, we're going to take our known fraction, 1 over 8, set it equal to 1 over x, and then cross multiply. Again, you're probably thinking, well, I didn't really need to go through all that process to find x, and a lot of you probably didn't. But I think you'll find some problems later on get a little tougher where this pattern is going to help you out. And then we're going to do the same process to solve for y. So we're going to use the same fraction, 1 over 8, that we used in the last problem, and we're going to set it equal to radical 2 over y. We're going to multiply the cross products, so we get 1y there. Multiply the other way, 8 times radical 2 is just 8 radical 2. So the three sides of this triangle are 8, 8, and 8 radical 2. That follows the 1, 1 radical 2 pattern. Those are just scaled versions of that pattern. So let's look at a 30, 60, 90 problem. Sometimes when people use the formulas here, they forget which one's double and which one's radical 3. So to simplify this, I just like to use these patterns. So 1, 1 radical 2 is the pattern for 45, 45, 90. 1 radical 3, 2 is the pattern for 30, 60, 90. And those numbers get increasingly bigger. Radical 3 is bigger than 1, 2 is bigger than radical 3. So there's our three fractions. Here's the 30-degree angle. The side opposite the 30-degree angle is an 8, so it's going to go here. The side opposite the 90-degree angle is a y, so it's going to go underneath the 2. There's 180 degrees inside a triangle, so that means this angle has to be 60. The side opposite that 60-degree angle is x. Doesn't matter which one you solve for first. Y is easier to solve for, so I'll solve for it first. So I'm going to set 1 over 8 equal to 2 over y. Again, you have to know the top and bottom of one of those fractions for this process to work. We cross multiply there, we get 1y. We cross multiply the other way, we get 16. So the y value is 16, and now let's solve for x. So you're going to use that same fraction, 1 over 8, set it equal to radical 3 over x. We're going to cross multiply, you're going to get 8 radical 3. The other cross product is going to be x. And again, some of you are saying I probably didn't need to use those patterns. I probably could have just doubled that smallest side to get 16 and then multiply that by radical 3 to get that side. If you can do that, absolutely use that method. A lot of people cannot. Encourage you, try number 3 and number 4, either doing it your own way or using the pattern method. Pause the video now. So there's the process to solve for x. Some of you may have canceled out the radical 2's here and made this fraction 1 over 7. That would have been completely fine. I did not process that. I went through, but I would have gotten the same answer. And one thing you do want to start recognizing with the 45, 45, 90, the two short sides, the two legs, are always going to be the same for a 45, 45, 90. So if x is 7, so is z. I'm going to go through number 4 and then have you try the last 3 on your own. I'm not going to go through number 5 this time. So number 4 is a 30, 60, 90 triangle. So that means automatically it's 1 radical 3, 2. You still have to memorize this pattern, but if you just kind of just know it's 1 radical 3, 2 in that order, 30, 60, 90, you don't really have to cram your brain of which one's double the other, although you can kind of see it with these formulas. The 30-degree angle would be up here, so the side opposite the 30-degree angle is x. The side opposite the 60-degree angle is y. And the side opposite the 90-degree angle is 15. This time I'm going to solve for y. Solving for y is a little harder, but you'll have to do it eventually anyway. Again, we know one of the fractions, 2 over 15. I'm going to cross multiply, you get 2y. I'm going to cross multiply the other way, you get 15 radical 3. Divide both sides by 2. You could write this as 7.5 radical 3. Or you could just keep it as a fraction. A lot of times multiple choice tests I've noticed like that second answer, but either one of those is acceptable. And then x, solving for x, much easier because all you've got is whole numbers. 1 over x equals 2 over 15. Cross multiply, we're going to get 2x equals 15 divided by 2. X is either 15 over 2 or 7.5. Pause the video and try those your turn problems on your own using any method that you like. So this first one, this is the process. I did want to mention something here from Algebra 1 and probably geometry as well. You go through this process, you get 16 divided by radical 2. You're not allowed to have a radical at the bottom of a fraction. So what we have to do is we have to do something called rationalize the denominator. So we've got to get rid of the radical at the bottom, and to do that, you're going to multiply radical 2 times itself. I don't have enough space, so I'm going to write the answer right here. You're going to get 16 radical 2 across the top. Radical 2 times radical 2 is radical 4. Of course, radical 4 is equal to 2, and then 16 divided by 2 is 8. So that's our answer for x. Here's the answer to the next one. Notice I made this one a lot easier by just canceling out the radical 3's at the beginning. If you don't do it at this point of the problem, it's okay. You can still cross multiply. You'll eventually cancel out radical 3's anyway and get the same answers. And there's the answer to the last one.